So welcome students. In this video, let us look at how to find the square root of a complex number. So let us say that you have a complex number z is equal to x plus iy and you're asked to find the square root of this. That is, you're asked to find root of x plus iy. So to find this, let us assume that the square root of this is a plus ib. So if square root of x plus iy is a plus ib, then what is the condition that a plus ib has to satisfy? This implies x plus iy has to be equal to a plus ib whole square. So remember, in this question, x and y are given to you. You're asked to find a and b. So that's what your aim is. So that is equal to, so what is a plus ib whole square? This is of the form a plus b whole square. So a square plus I square b square plus 2iab. That is equal to a square. I square is nothing but minus 1. So a square minus b square plus 2iab. So x plus iy is this complex number. So this implies if two complex numbers are equal, the real parts have to be equal to the real parts, and the imaginary parts have to be equal to the imaginary parts. So x will be equal to a square minus b square, and both have to be equal. Y should be equal to 2ab. Y should be equal to 2ab. So from these two equations, can I find the values of a and b? Yes. So a square minus b square is x, and 2ab is equal to y. So from these two equations, can I find a square plus b square? So we know that a square plus b square whole square is equal to a square minus b square whole square plus 4 times a square b square. A square minus b square, a square plus b square whole square is equal to a square minus b square whole square plus 4a square b square. So that is equal to, what is a square minus b square is equal to x. So this becomes x square plus 2ab is y. So 4a square b square becomes y square. So this implies a square plus b square is equal to root of x square plus y square. A square plus b square is root of x square plus y square. So you have a square minus b square with you, which is equal to x, and you have a square plus b square with you. From these two equations, can you find a and b? Yes. So 2a square is equal to root of x square plus y square plus x, right? And a square is equal to root of x square plus y square plus x by 2. Next, if you subtract one from the other, 2b square will be equal to root of x square plus y square minus x. So this implies b square is equal to root of x square plus y square minus x by 2. So it implies a is equal to plus or minus of a big square root of x square plus y square plus x by 2, and b is equal to plus or minus of a big square root of x square plus y square minus x by 2. So now you got two values for a and two values for b. So effectively for a and b, you have got 4 different values. That is, plus plus gives you one answer, plus minus gives you another answer, minus plus gives you an answer, minus minus gives you another answer. So you have a total of 4 different answers for square root of x plus iy, which cannot happen because you can only have 2 square roots for a given number. So out of these 4, only 2 of them will satisfy root of x plus iy. So how do I find it? I find it from this equation. So once you get these numbers, so you have to go to this. Now y is equal to 2 times a into b. So if y is positive, that is, if the given complex number has a positive imaginary part, this implies if y is positive, implies a into b has to be positive. That means a comma b have the same sign. So if y is positive, then a and b should have the same sign. And if y is negative, that implies a into b is negative. That means a comma b have opposite sign. So effectively, if you summarize this process, so you'll be given x plus iy, you'll be asked to find a and b. So first what you do is you find the values of a and b. Root of square root of x square plus y square plus x by 2. Root of square root of x square plus y square minus x by 2. Plus or minus, plus or minus. So you have these two values, which are very straightforward. Next you need to look at the value of the given y. That is the imaginary part of the given complex number. If y is positive, then take either both positive or both negative. If y is negative, take one positive, one negative, one negative, one positive. So that gives you two possible square roots of a complex number. So let us take an example and summarize this process. So the algorithm to find the square root of a complex number consists of two simple steps. So in the first step, you need to find the values of a and b. So a is nothing but a big square root of x square plus y square plus x by 2 plus or minus, and b is equal to plus or minus of a big square root of x square plus y square minus x by 2. So in the first step, you just need to find these two values. In the second step, check whether y is positive or negative. That is, in the given complex number, you just need to check whether the imaginary part is positive or negative. So if y is positive, a comma b have same sign. That is, take either both positive or both negative. So if y is negative, a comma b have opposite signs. So if y is positive, you get two square roots. If y is negative also, you get two square roots. So these two will be the answers to the square root of x plus iy. So now let us take some examples and see how to apply this algorithm. So let us take a sample question. So the first question is, you're asked to find square root of 8 plus 6i. So let us try to use our algorithm to find the square root. So the first step of finding the square root is to find two numbers a and b. So a is equal to plus or minus square root of x square plus y square, that is 8 square plus 6 square, plus x, that is plus 8 by 2. And b is plus or minus square root of 8 square plus 6 square minus 8 by 2. So that is equal to square root of 8 square plus 6 square, 64 plus 36, 100, square root of 100, 10 plus 8, 18 by 2 is 9, that is equal to plus or minus 3. And what is b? That is equal to plus or minus square root of 10 minus 8, which is 2 by 2 is 1. So square root of 1 is equal to plus or minus 1. This is the first step. Once you find a and b, the first step is completed. Next, the second step is to check whether the imaginary part is positive or negative. So the imaginary part 6 is greater than 0. That means a and b should be of the same sign. So this implies square root of 8 plus 6i is equal to either plus 3 plus I, 3 plus I, or minus 3 minus I. Minus 3 minus I. Or you can write it directly as plus or minus of 3 plus I. You take the same signs, both plus signs, and you write plus or minus outside. So I hope you can understand the process. Next, let us go for root of minus 8 minus 6i. So here also, the first step is to find a and b. So a is equal to square root of minus 8 whole square plus minus 6 whole square. Once you're squaring, it doesn't matter whether it is positive or negative. So root of 8 square plus 6 square plus x plus real part. Here real part is minus 8. So plus of minus 8 is minus 8 by 2. Plus or minus, that is equal to plus or minus of 10 minus 8 is 2 by 2 is 1. So plus or minus 1. And b is equal to plus or minus of square root of 8 square plus 6 square minus x, that is minus of minus 8, that is plus 8 by 2, that is equal to plus or minus 3 as we have done here. Now you got both a and b. So now in the second step, look whether the imaginary part is positive or negative. So here minus 6 is less than 0. The imaginary part is negative. So a and b should be taken of opposite signs. So this implies root of minus 8 minus 6i is equal to a is 1, b is minus 3, that is 1 minus 3i, or if you take a as negative, b has to be taken as positive. So 1 minus 3i or minus 1 plus 3i. So these two can be written as plus or minus of 1 minus 3i. So the square root of 8 plus 6i is plus or minus of 3 plus I. Square root of minus 8 minus 6i is plus or minus of 1 minus 3i. So next, let us try to find the square root of minus 8 plus 6i and 8 minus 6i. So here also let us use our algorithm. So the first step, let us find a is equal to plus or minus of square root of 8 square plus 6 square plus real part, that is minus 8 by 2, that is equal to plus or minus 1. And b is equal to plus or minus of root of 8 square plus 6 square minus of real part, that is plus 8 by 2, that is equal to plus or minus 3. So you have plus or minus 1, plus or minus 3, a and b. So once you have a and b, the second step is to see whether imaginary part is positive or negative. Imaginary part is 6, which is greater than 0. Hence, both a and b should be of the same sign. So this implies root of minus 8 plus 6i is equal to plus or minus of 1 plus 3i. I hope you understand how to write this directly. Next, root of 8 minus 6i. So the first step is equal, a is equal to root of 8 square plus 6 square plus 8 by 2, that is equal to plus or minus 3. b is equal to plus or minus root of 8 square plus 6 square minus 8 by 2 is equal to plus or minus 1. This is the first step. The second step, the imaginary part is negative. Hence, root of 8 minus 6i is equal to plus or minus of 3 minus I. Plus or minus of 3 minus I. So in this way, whatever numbers are given, so you can find the square root of the given complex number in 2 simple steps. Thank you.